So I'm going to record on here. That way Wade or anybody that's missing can see the lab instructions on YouTube, and then they could pause the instructions and do lab 22 sometime, remote PCN or something. Let me make sure that is recording. Yep, it does show that's recording. So yeah, pause right now, do that lab if you're watching it on YouTube. And then remember, you have to log in as user 1. You could do your like Control-Alt F2 or Control-Alt F3, log in as user 1, secret the password, and type that in your Linux machines when you get to that point to start CPU busy. And what do we have? 1 to 2 seconds is what it should show up around step 5, and somewhere between 0 and 1 second when you change the share values on one of them, and somewhere between 2 and 6 seconds or so for the other one. Should be a little bit of a difference. Did everybody experience that? 0, 1, and 3 and 4. So a little bit different for everybody, but oh, I didn't mean to check on that. So now we're moving on to I think we've already done this section here with the share values. That's what the lab was, changing share values, seeing how that you can, if you got a voice over IP server, probably needing it a higher share value than some of your others. Anything that's real time. This is one method, is dealing with shares. Next one, monitoring tools that VMware provides. Of course, I've also showed you that Beam1 dashboard. It's really, really cool. Of course, that does cost a lot of money. So monitoring tools within VMware allows you to help fine tune what your share values and things could be. So I did notice you haven't removed the affinity yet on those virtual machines. Must mean they're still going to be using them in 23. Some point in time, we will have to remove the affinity because you can't migrate if affinity is stuck on. It's not something you keep on in production. It's only for demonstrate the lab capabilities in the lab environment. For now, it doesn't say to change anything, so we'll look at what lab 23 when we get there. So performance tuning methodologies. Big orange block here. Don't make casual changes to production systems. Just meaning don't make changes just for the sake of making changes. Is there an actual reason why that you need to make a change? And what's going to be the result of that? And instead of just try, test it out in a testbed environment. I think Wade discussed AutoLab in his presentation, where you could set up a cheap server like at home, put AutoLab on it and simulate several ESXi servers and be able to log into them and make some changes just to see what the results might be before you start experimenting on your production system. It's not good to experiment on a running system. So what do you have to do? Check out your performance. Preferably do it before things go bad. Keep benchmarks and stuff. Cool thing about vCenter Server, as long as it doesn't crash and the metrics get deleted and the database gets deleted, you can have a history, a year's worth of history. So you can look over the entire course of the year when things get busy or not, maybe tax time or inventory time or spring break or something like that, you can monitor overall over the course of a time period. Identify the limiting resource. Just as we talked about in LAN 1 and LAN 2 courses, always check RAM first to make sure it's not the limiting. If you have a couple of things that look like they're the bottleneck, if RAM's one of them, it may be the sole issue. It can make other things look bad, especially in a data center where that you're using remote storage. It can make the hard disk look like they're bottleneck when you're actually just using a lot of vSwap, and all your hard disk is using because you're having to swap out because you don't have enough RAM. So always verify RAM first, monitoring stuff. So you can allocate more resources, reduce competition, log your changes, benchmark again, change share values, shut stuff down, set limits on certain machines that are trying to hog the network. You can even configure the input output per second for the hard disk and stuff on the VMDK files. How much access will they have to the storage? Try to reduce competition. It's very granular going to the individual virtual machines and doing that, but can be done. You can check stuff. Maybe you're not the VMware server administrator. Maybe you're just administrator of Active Directory or Exchange server or database server or something like that. And you don't have access to look at the VMware side. Well, since you've taken this class, maybe you don't get a job in this, but you still know about virtualization. You learn here that VMware Tools installs extra drivers into Linux and Windows. Most specifically, Windows has a performance monitor, and a new DLL is added to performance monitor where you can go in and they add a section to view VMware. You can actually see what the host is doing. So if you're looking at your performance task manager and your CPU is pegged at 100%, you can go, well, let me go look at the actual physical server that this thing's running on, and are they allowing me to use the whole entire core or not? So you go in and check the, what megahertz core you're running on and what percentage of the physical server. And sometimes you can see that, hey, they've set a limit on me. You know how we set that 5 megahertz limit? So you could do that. You could verify if there's ready values or not showing up, what type of competition, just by using the performance monitor in Windows. Here's the Windows Task Manager. That's just looking at Windows tasks to see what's going on, but doesn't give you a good overall picture on, are you having competition with other people? And yeah, the company you work for, they may be renting out computing power from someone. I think some of y'all work for Network Services Group, right? Daniel and SG. Who works for there? You work for them? I'm not calling them out, but the people that are working or renting stuff off of a cloud provider probably have a service level agreement. And you could check, am I actually getting what I'm paying for without even having the rights to see, log into the VMware side. You can look, it's likely your cloud-based OS is running as a virtual machine somewhere. They used to actually rent out physical servers before virtualization back in the 90s. And early 2000s, but now everything's cloud-based. Here, using Performance Monitor, you can go into your charts and stuff. You can even see that like from Task Manager. So let me show you. So we got Task Manager. Actually, no, that only opens Resource Monitor. Resource Monitor is not the tool you need. You actually need Performance Monitor and add a counter. If you're running as a virtual machine, you would see some VMware stuff down here. I'm not, so I don't have VMware on this one. So looking right down here, you can look at the VM memory. You can check to see if there's any limits or anything. Let me zoom that in. Here's the limit in megahertz. So what do they have? Got this spread out. Apparently they've got clicked on. I don't think these two match up on what they've got clicked on. I think there's another section for VM CPU underneath it. I think they've got this plussed out and it does show that highlighted, but I think these are two separate windows. I think they photoshopped some stuff. Doesn't seem consistent there, what should be, but you can look at the CPU and you can check what's going on. Do I have a limit or not? No limit set here. That's a good thing. But you might see like 500, go, hey, it's not what I'm paying for. ESX top to monitor VM resources. This is primary tool for vSphere. Run it from the ESXi shell. You can install vSphere CLI, which is a set of remote tools inside of a guest operating system or inside of any operating system. You can log into the vCenter server and then run the RES remote server top command. I want to check out our CentOS machines. Yay, my Chrome's up to date. Thank you. What do we have running? We've got Hudson's running. I'm just looking at the VMware tools. So I didn't see. RES X-Top, I don't think is available. Nope. So if you're renting out a Linux machine for these vSphere CLI to actually work, you'll have to install it separately, and you'll need a login to the vCenter server to be able to see that. A little bit of downside on that part, but your Windows machines, you'll have the performance monitor, but you're probably renting Core. I don't know, the performance monitor runs on Core. I don't think they have that. I'd have to check on Core to see. I don't think it is. You don't have a GUI, so. So vSphere statistics. You have stuff for clusters, hosts, data stores, network, and virtual machines. You have a lot of different monitoring objects you can click, view things from a different perspective. You know, you can look around your yard. You get a drone and fly it up and look from up above and see different aspects of stuff. That's sort of what the different layers are. You can have water pipes, sewer pipes under the ground. Get like a little scope or something and have to run it down different pipes to see if you can find a leak. So sort of different areas you can look at. I guess the network would be kind of like the water pipes, looking underneath things. The data store, that'd be your garage. You can't park your car in because it's so full. Your host is your house. Your virtual machines are the people living in your house. Your clusters would be an apartment complex. A bunch of people live in one building. Okay, so moving on. Working with performance charts, you can view just an overview, and it shows you just some basic overview of your actual ESXi host or virtual machine itself, CPU, memory, disk, memory rate. You can also click on advanced and you can change it from just an hour snapshot. And under advanced, you can drill down and look at individual charts and look at things over a period of time, real time through yearly. You can adjust the charts too under advanced. Most of the charts are probably going to show an aggregate or everything. So if you've got a host that's got 12 cores in it, and you're looking at the processor, you might see a line that's the average of all of them across. And depending on how it's configured, you may also see like 12 other lines for each individual core. So you're going to adjust the chart on what do you want to see. You want to look at a particular core, you want to look at all the cores separately, or do you want to look at everything combined as a total average on the CPU and not look at individual cores and threads. So you can go in and check that. Same thing with network. You have more than one network adapter. You can look at an aggregate total bandwidth in and out of the entire server, or you could look at particular instances of network adapters or ports in the system. Most charting tools have that. Windows Performance Monitor has that. So you can see there's the top checkbox, which is everything or the individual. You notice it starts counting at 0. It's probably hard to see that 0 right there, but the first device, computers like to start counting at 0. This is device 0. It actually exists. There's something here. 0 is not nothing. It's a placeholder in computers. Also under advanced, like I said, you can view the chart in different modes, real time. It shows you an hour chart. And what are you looking at? Each data point is 20 seconds. Every 20 seconds, it records a value. and builds the chart. There's 180 of those in an hour, because that's 3 per minute, 20, 20, 20, 60. So 3 per, that's your 180. If you click on past day, the past day, what it does is every 5 minutes, the database will average will average 15 data points into one and record a value. And then it will use those data points to show a chart over a 24-hour period. There's 288 data points on your chart looking at a day value. But you also got to think you'll see less spikes and stuff. You know, real time, you can see some more spikes than you would at 24-hour. Then you get to past week. It takes 6 of the past day data points, adds them together and averages it out and stores a data point for that. So that's every 30 minutes. And then it keeps doing that the past month, every 2-hour data points. And the past year, it only shows you the average every day. So it's really granular. You don't see, you're seeing daily spikes of stuff, but you're not seeing what would happen in like between 2 and 3. You wouldn't be able to see that there's a spike between 2 and 3 because it would average that whole entire 24-hour period as one data point. And of course, 365 data points for a past year. But it's good to look at, you know, yearly. You're looking at overall what's happening each day, month, or week, sort of what you're looking at. Probably if you're a retail store, you probably see stuff start spiking up in October leading into Black Friday and holiday sales, and you can watch it gradually come up and then see when it drops off after the first of the year. Potentially, maybe not. Chart types, bar and pie. They provide you different chart types. Stacked line charts. I think there's a line chart. I'd have to look, but they do have bar and pie charts. Why? They realize that certain senior management likes a particular chart. They understand a particular chart. They don't understand the other one. Some will understand line charts. Some will understand bar charts. Some will understand pie charts and stuff. You can even export this data points into a CSV file and import it into Excel or some other type of presentation tool, and maybe build a Gantt chart or anything else that you need, that your bosses like. It's one thing you got to do. You have to be diplomatic. And if you want money, you need to know what the person likes that you're presenting it to. Sometimes you need to network with other people in this company. So what does this CEO want to see? You know, I got to show this to Elon Musk and get some money. What does his eccentric self want to look at? Should I make a star background or show a Tesla Roadster in the background of the you know, what do I need to like spice it up? Seriously, that's how you get money. And show them like, yeah, we're increasing at this rate, and by 2 months from now, we'll be out of capacity. So we need to buy these 30 new servers for $2.3 million. Like, why should I give you $2.3 million for 30 servers? If you don't show them the right chart, you might not get it. Then you might get fired for not being able to present it correctly and get the money to not have the company in dire constraints. But I tried. There's a lot of diplomacy there. Line charts, just another form that a boss might like. Stack charts. You can save a chart as notice. PNG, JPEG, SVG graphic, or a CSV file. You're probably most familiar with PNG and JPEG. You should also be familiar with CSV, comma separated value, because we imported 100 users into LAN class with the CSV file. So that should make sense to you. You'd have to import that into a database, Excel or something, and do your own charting. Counters. Look at individual cores, look at the aggregate. I already talked about that. So. Statistics being showed, you have a rate, that's current rate. So if you're looking at the CPU, you're looking at the rate, it's showing you right at that like 20-second interval. If you're looking at real time, how many megahertz was being consumed by the processor at that point. Delta would be, how did it change from the last data point? Is it going up or down? What's the change? And then absolute. It's not really, the CPU changes a lot, memory or like hard disk size or something like that would be in more of an absolute value. There's all the roll-ups I just talked about, the different timing. There wasn't a lab on that one yet. Let me go look at, we've not been running for very long. This one has, however, been running for a while. And this vCenter server. So my ESX10 has been running Active Directory. It's been running the NFS server that's got the share folder on it. It's also been running the vCenter server. So looking at my ESX host, this is probably the best one to look at for a long term. Like I said, I'll go under advanced. And here under advanced, there's real time with the CPU. So I can see spikes. It's probably running. There's core 8. So I can see all the different cores. I've got apparently 23. 23 logical processors. Looks like it's load balancing it pretty good across cores. But here I can go to the last day. (6:55 p.m.) There was a spike on the 6th. Probably some type of process, daily process probably run on that. Let's check week. Let's see if there's a 6:55. If I look at weeks, notice it's a little bit more leveled out because now the averaging is over was it a 30-minute time frame? I think so. 6:30, 6, look, maybe 6:30. (6:30). So I see a trend here. Looking at the day, I can see 6:50. So it's averaging, it looks like it's averaging from like 6:30 to probably like 6:59 and putting that as a 6:30 data point. So the 6:50 is probably happening every day right around 6:50. I bet it's a cron job or something that runs. So charting can show you stuff like that. Okay. Something's running right here. Maybe customers are complaining that it's running slow during that time. So I can log into the system and check all of the scheduled tasks and see if there's something that I could do to maybe change when that runs. Maybe that's right before closing time. I might be thinking like, well, it's just closing time. It gets really busy right there, but could be just like a defrag or who knows, some other type of volume shadow copy service running during that time. So go check all the scheduled tasks on the Windows Linux server, and maybe you'll see something starting at 6:50. Okay, I'll bump this an hour. I'll move it off closing time. Have less complaints. So a lot of things these charts could do. Past month, still see that tiny blip all the way across. So there's the last year. There's some gaps in the chart. Probably during periods where we had power outage and it was over the summer or spring break or Christmas break or something, and I wasn't here to turn them back on. Look at individual virtual machines. Last year. It's probably Windows updates. Probably those spikes. What about this one? This one's probably more entertaining. Nah, not really. Similar scenario. Memory. Chart options. Add in some swap rate. So here I've looked over the entire last year for this particular vCenter server. And remember I talked about vSwap file? What happens if you start swapping? Until you've way over committed stuff and people are angry. Customers aren't happy. Have I ever swapped in the past year? Was there any point in time where I was running low on memory and swapped out of the past year? No. Because I see the maximum, it never hit a swap. So that's good. If I seen swap happening, then I'd start looking up here. Was it just something transitory? How long have I been swapping? Now I need to start investigating RAM. What's going on? Do I need to migrate something off? So yes, monitoring is really, really important. Interpreting data. I think I just showed you all of this stuff. Constrained virtual machines. Chart options. I want to check if my virtual machine's ever been constrained. The ready value. that right there has it ever been constrained? Apparently it only has a real-time chart for that. Or I can. That's usage. That's not what I wanted. Ready. Okay, they don't have a long-term. It's only keeping track of readiness over the real-time past hour. Don't have any long-term on that one. It's pretty low, but there has been some times that it looks like the virtual machine wanted to do more than the processor could handle. At 1/10 of a percentage point. It's not much. So low constraint, that's good. Seeing this line at the bottom. Memory constraints, like I said, looking to see if ballooning or swapping out is happening. That's your key indicator that you're running low on RAM. Disk constraints. Check for disk queue length. Look at the latency in milliseconds. You shouldn't have anything over 15, 20 milliseconds. When I first started, I was trying to do storage vMotion, and I was getting 1,000 to 4,000 milliseconds hard disk latencies. It's like, that's probably why that it's taking hours and 6 hours to move 2 gigabytes from one drive to another. Like, it should not be that slow on RAID 5 or RAID 10, whatever, between one system to another. That's where I got to researching, why am I getting, because the specs were, you should be under like 20 or 15. Yeah, that's way over. That's like 3 seconds for every write operation. Like, computers don't run that slow. Well, it was. It was not working at that speed. Who wants to play a game with a 3,000 millisecond ping rate? Most of the time it just disconnects. If it gets up even to the 500, you're like, oh, this is crap. I played a game with my friend over dial-up. We dialed into each other's computer back in the day, and I don't know what the milliseconds was. We're playing Quake 2. We'd run into the room. We'd shoot each other for about 30 seconds. So I bet one of us killed each other, and we'd go run away from each other, and we'd play the game for about 2 minutes, and then one of us would explode. So we had like 200,000 millisecond delay. It was hilarious, but that's not hilarious when you're running a data center and people are trying to make phone calls and send emails and visit websites and buy stuff. And yeah, that's not funny. That's where I found I had to have batteries on the RAM chips that brought down the millisecond down into like 5, 3, 2, and now is transferring in 2 minutes instead of 6 hours. That was the change difference. 2 minutes, I can handle 2 minutes, I can't handle 6 hours. So hugely drastic change. So some of these metrics are good to look at the physical device, look at the command latency and stuff on it. See if you got some type of constraint. Sometimes the constraints will spike up, 2-3 years from now, you're like, wait, why is my latency all of a sudden going up into the hundreds or thousands? Your battery, if you haven't changed it, it's probably worn out. Most of the batteries can be recharged a set number of times, about 500 times, and they're worn out. So if that battery on that RAM chip, have you ever had a cell phone where the battery starts getting old and weak? Sometimes they start swelling up, breaking the circuit board and stuff in the phone. They do the same thing. Luckily, the batteries are normally like tethered and they're hooked on the side of the case, so they expand out. They're not expanding out and pushing the RAM chip, breaking things like it does in a phone. But yes, had that happen. Like latency's jumped up. I go pop the side of the case and I see that the battery's bulged out. It's no longer functioning. So it turns off battery backed write cache speed. Monitoring virtual machine performance. We've got to create a CPU workload, use performance charts and monitoring the CPU usage, remove CPU affinity, change CPU shares to normal. Well, it does look like we're supposed to keep those affinity rules and share values set. So you can take a break before you start this lab. Let's check out the lab, see if there's anything I need to modify. Again, you're going to use your 11 and 12, not 2 and 4. Use the 2 you used in previous lab. I think it'll have that brain capacity. I believe in you. So you're checking. Looks like you're starting up CPU busy on both of them again. Yep, starting up CPU busy. And you're just doing all of this lab again. 11, use it in place of 2, and 12, use it in place of 4. So take a break and do lab 23 with those 2 virtual machines. Okay, so using alarms, after you completed lab 22, we've got use predefined alarms, view and acknowledge alarms, create custom alarms. So all about alarms, yeah, there's predefined alarms that go off. If you enable SSH, you get a warning alarm. Hey, SSH is enabled, you're not secure, you should turn it off. When the CPU spikes and goes over a certain threshold for a period of time on VMs or the actual host itself, you'll get little red and yellow exclamation points and circles and stuff by your virtual machines or host. So those are called predefined alarms. So that's great. Again, they have a subset of a certain set of predefined alarms. The Beam1 I showed you, that expensive product, they've got a lot more of them predefined and dashboarded. So I think when we connected in, it already showed us a few virtual machines that had snapshots that were too large, snapshots that were over so many days old. So it has more alarms than what's defined in the vCenter server. You can edit predefined alarms, although I don't know if you really want to edit a predefined alarm, you probably want to add a new alarm, leave the predefined ones alone. If you edit predefined alarms, what's going to happen when you upgrade the vCenter server in the future? they could potentially get lost or reverted back. Likely not, but there is a potential for that. So creating your own alarms would be a better route to go. So creating a new alarm definition, you can select what are you going to be setting an alarm on: virtual machine, host cluster, data center, data stores, the networking like distributed switch, or the vCenter server itself. So you can choose the components you want to get the alarm on, and then it will give you different values that you could create an alarm on based on what component. You wouldn't want to set up a storage alarm on the CPU. It wouldn't make sense. CPU doesn't have storage, so that's why you got to choose which alarm. And then triggers. You got to have at least one trigger on your alarm. So when that is pulled, the alarm goes off. And most of the time you have like a double trigger. You have a warning and an error trigger. Well, same type of trigger, but two different pull levels, I guess. So you can create, you can create snapshot site alarms. You can check other events that occur. So monitor state of an object or events. So an event's license is expiring versus a condition. The CPU is running over 80% utilization for more than 5 minutes. That's a condition that has occurred. Network cable come unplugged. That's an event that happens. So you kind of got two different types there. That you've got events that happen. It's like the one time it's basically it broke completely. So things like that versus conditions where you get something goes over utilization over a certain amount of time. You don't want to do the CPU like it hit 100% for a second because the CPU spikes quite often for transient workloads and stuff. And you'd have too many alarms firing off if the timing was too short. So yeah, you can create all type of triggers, and they're different for what component you're looking at. Once the trigger is activated, what happens? Do you display something in the vCenter log? Do you send an email? You send a SMTP or SNMP command out to an SNMP monitor? What do you do? Do you run a script? Maybe the script connects, logs into a voice synthesizer and dials a phone number and reads the alarm. You ever see those YouTubes where it's like listening to somebody has a computer reads Reddit to you or anything like that? No. Rick looked up like, yeah. So run a script. You can have it actually call or do something. And then reset. So what would reset the alarm? And then once you're done, you can enable the alarm. It's not enabled by default. So once you create it, you have to make sure the slider down there is turned on. Otherwise, you'll create it and you'll be waiting for the alarm to happen and it never works. Why doesn't it work? Because it wasn't ever enabled. If you are going to have it send email or SNMP traps and stuff, you need to edit the vCenter server and provide the credentials or locations that emails or the traps and stuff are going to be sent and received. Otherwise, it's like, send an email. Okay, how? You got to tell it how. Computer's not very smart. Let's look at alarms real quick, see. So where can I find alarms at? Set alarms on the vCenter server itself, on ESX stuff. Let's look at I'm under, I need to better configure alarm definitions. So these are the built-in alarms. And I can add alarm. I'm not sure. Just looking. So target virtual machines. I'm going to look around, see what alarms I can set on virtual machines. Just playing around. I'm not have anything in mind right now. Select a trigger if. CPU ready. Usage. Memory. Their snapshot size. I was looking for like snapshot age. That's something that Beam has. They track snapshot age, so you can spot anything that got stuck in a snapshot mode, but I don't see that type of alarm. So that's what I was looking at. So let's see, look here, CPU ready time. So is above 100 milliseconds for 5 minutes, then trigger a warning, add additional triggers. CPU ready time is above 300 milliseconds for 5 minutes. No, I don't need that. I'd have to create a second alarm. There's alarm rule 1. Set as warning. Duplicate rule, alarm rule tool 2. If it's above 3,000 milliseconds for 5 minutes, show as critical. So I can have 2 rules in one alarm. So I can have a warning state and then a critical state showing up either yellow or a red. So if the warning critical conditions are no longer met, it's the default rule. Reset it to normal. So here we go. We have yellow, red, and green states of alarms. This dialogue's a little bit different than the older dialogue, the older versions. You actually have to do state change drop downs if you want to go from green to yellow or from green to red. If you're at the 100 millisecond or the 300 millisecond threshold, and it would jump to one of those states. So I'm going to cancel that, but hey, it is enabled. Said it was disabled by default, didn't it? Okay. This is a patched version of vCenter server. So apparently they changed the defaults. That happens a lot with the curriculum. And you'll also notice that a lot on when you're out in the field. You'll study a product and then you'll install a patch and it changes what the defaults are. It's a never ending. That's kind of why it's good to have those templates to deploy virtual machines out, because they're always got the same state when they're deployed out. So I'm going to cancel that, but yeah, you're going to be creating alarms. You can also do things such as disable alarm actions temporarily across the board. You can disable alarm actions on host or individual virtual machines. So alarm actions can be controlled on the particular or different hierarchical levels. The reason you'd want to disable alarm actions, you're about to do something crazy for a little bit and you don't want a whole bunch of alarms popping up on, say, the dashboard somewhere and go, hey, look at this. Using vRealize operations is monitoring all of these, and a big 75-inch monitor on the wall, the knock center. So disable alarm actions so the people in the knock center don't try to jump in and start fixing stuff because you're needing to make a change. And like, no, I don't fix. I'm trying to break it for a second, actually fix something. And so that does happen when you need to go do some maintenance. Alarms will start throwing off. So it's on there on purpose. If you're going to do something drastic, that you disable alarms so you don't alert people overseas or something. Because depending on who you work for, it's going to be maybe working in a large team. Okay, let's look at the lab here on alarm actions. Using alarms, you're going to log in, and remember your O2 is we're going to use our 11. So you're going to set up a custom CPU alarm and probably use CPU busy to help trigger the alarm. I don't see anything in here that's cumbersome other than you need to use your VM11. Yep. So we'll go ahead and run through lab 24. That will be our lab for today, last lab today. Mm-hmm.